we're given the following information. It says determine if the given function y equals f of x is a solution of the accompanying differential equation. So this right here is the differential equation that we're going to be investigating, but we're going to be utilizing the function that they gave us, which is y equal 1 over x plus 5. So we're going to do a few of these examples, but what it's telling us here is that if you take the derivative of this function y, then it should be equivalent to the opposite of y squared. So our job here is to prove that this is the case, or disprove it for that matter. So all we need to do is check, well, does it match? Okay, does it match? Okay, so what we're going to do is we're going to take the derivative. And the only way I think, well, this one can be done a couple of different ways. This one right here, you could use the quotient rule. You could use the chain rule. I think we should just use the quotient rule just for the practice on quotient rule. So I'm going to write out high and low. This is the way that I write it out when I'm talking about the quotient rule. I say high, which is the function on the top, in this case 1, low, the function on the bottom, which is x plus 5. And so I find d high, which is the derivative of the top, to be 0, and d low, which is the derivative of the function on the bottom in the denominator, to be 1. And so I write low d high, which is x plus 5 times 0. So this is our derivative y prime. All right. And of course, all of that's going to go to 0, minus high d low. Okay, which is 1 times 1. Okay. All right. Over low, which is the bottom, the denominator, squared. Okay, so what does that work out to be? Negative 1 over x plus 5 quantity squared. Okay, so our job, now that we have found the derivative y prime, is to verify that the relation exists, and that is that y prime is equivalent to the opposite of y squared. So what we're going to do is we're going to check what we were given, the differential equation that looks like this. And so we're going to substitute what we know for y, the opposite of 1 over quantity x plus 5 squared. Okay, so we are going to follow the order of operations, and that is to say that we have 1 squared, all right, which is just 1, over x plus 5 quantity squared, and all of that's going to get multiplied by a negative 1 that resides on the outside. So our final solution here is that negative 1 over x plus 5 quantity squared is indeed, in fact, y prime. So because these two things here, these two statements here, match, all right, the question is y prime a solution to the function a solution of the differential equation? And the answer is yes. All right, the answer for this is yes. Why? Because they match. All right, they do match. So it is a solution. All right, we're going to go ahead and take a look at another example. Okay, in this next example, we're following kind of the same process. What we're going to do, though, what I'm going to do is I'm going to isolate our y prime. That'll make it a little bit easier to work with. And that is to say that I can rewrite this and say that y prime, and I like to write this right here with so you can distinguish, y prime will equal 5e to the x plus y. Okay, so this is what we're going to verify. Okay, and in order to do that, we're going to have to take the derivative then of y. So if we want to find y prime, for example, we're going to take the derivative of each component. So in this case, the derivative of e to the x is simply e to the x. However, when we look at this next part here, we notice that we have to use the product rule, u and v. Okay, so we're going to apply the product rule here to find the derivative. And so let's check this out. Okay, if I have the derivative uv prime, I'm going to say, so plus u is 5x, v prime is e to the x, plus vu prime, which is going to be e to the x times 5, or 5e to the x. And so, now that I've got this in place, my job is to check if this indeed matches. And so, given what they've told us about y prime, okay, we're going to ask ourselves the question. 5e to the x plus y. Y was given to be e to the x plus 5x e to the x. And we can check component by component to see if this indeed matches. So we are going to verify between these two solutions here. All right, these two differential equations. And I'm going to do this by highlighting. So I've got a 5e to the x that's positive, 5e to the x that's positive. I've got a single e to the x. And of course, you could have combined like terms. That's not a problem. That checks out on both sides. And then I've got a 5x e to the x as well. So these two indeed do match. So the question, again, was to determine if the function y equals f of x is a solution of the differential equation. And the answer again for this one is yes, it is a solution. Okay, and let's go ahead and take a look at yet another example. Okay, now in this next and last example, we're going to be following the same process and very similar process to what we found in the last example. So what we're going to do again is isolate the y prime in this case. So that's what I'm going to start off by doing, and say that y prime equals 4e to the x plus y. And we'll figure out what that is in just a bit. But we're going to begin with finding the derivative. And so when we find this derivative, we have yet again e to the 4x. So it's its own derivative with the chain rule compensating here, in that we have to multiply by 4. So we get 4e to the 4x. And then we take the derivative by applying the product rule here with the u and the v. So we're going to say uv prime, so 4x multiplied by e to the x, okay? And then we're going to say vu prime. So we're going to say, okay, well, then that should be 4e to the x, okay? 4e to the x, so vu prime, 4e to the x. And now what we're going to do is we're going to check. Well, we need to plug in this material here, this information here, that equation, that function in for y, to verify y prime to see if these two indeed match. So let's figure that out. We're going to say y prime, and we're going to say equals 4e to the x plus, in this case, y. So we write it all out. 4e to the 4x plus, I'm sorry, that's not correct. Y is 4e to the x plus e to the 4x plus 4xe to the x. And now we can check off term by term to see if it matches. So let's see what we've got here. We've got 4e to the 4x, and I don't see that at all. So that should be a big hint. I've got 4x e to the x, that checks off. I've got 4e to the x, that checks off. But what doesn't check off is the e to the 4x and the 4e to the 4x. Okay, so these two terms here do not match. Okay, so to answer the question, again, the question being, determine if the given function y is a solution of the differential equation y prime, and the answer here is, of course, no. Why? Because they do not match. They do not match at all. So again, three really great examples of regarding differential equations and whether or not a function is a solution of a differential equation. So as always, I hope this video was helpful. And remember, like and subscribe.